Good morning students, welcome to my video lecture. First Brahmanath. Om Shanti Shanti Shanti. In last class we discussed principle of mathematical induction. Let Pn denote the given statement. Then step 1, for n is equal to 1, check whether P1 is true or not. If P1 is true, then step 2, assume that Pn is true for n is equal to k. Then step 3, using step 2, we need to show that Pn is true for n is equal to k plus 1. Last one, conclusion. It is true for all positive integral values of n. Okay. Today we are going to discuss complex numbers. We are going to discuss complex numbers. In our number system, natural numbers extended to integers to rational numbers to real numbers. But we cannot have a solution x square plus k is equal to 0, comma k greater than 0 cannot have a solution in real numbers. X square plus k equal to 0 cannot have a solution in real numbers where k greater than 0. Okay. In real number, we cannot find the square root of a negative number. In real number, we cannot find the square root of a negative number. Means square root of minus 5 is not defined in real number. Square root of minus 10 not defined in real number. Okay. So, but now, however, we can take the square root of a negative number, but using a new number. So, but it involves using a new number to do it. The great mathematician or renowned mathematician Leonard Euler was first introduced the letter I, small I, called iota, iota, where I is called an imaginary number is equal to square root of minus 1, that implies I square is equal to minus 1. Okay. The idea of complex number was given by Leonard Euler. Okay. The idea of algebraic equation was introduced so that all the algebraic equation could have a solution. In real number, x square plus k is equal to 0 is not a solution in real number. But after introducing a complex number, any algebraic solution could have a solution. Any algebraic equation could have a solution condition the coefficient of the variables are in real number. Coefficient of the variables are in real form. Okay. So I is the unit of imaginary number. Unit I, small I, denoted by square root of minus 1 is denoted by small I. The square root of minus 1 is equal to I, that implies I square is equal to minus 1. I square is equal to minus 1. Okay. yes, x square, the equation x square plus 4 is equal to 0 have no solution in real number. Okay, because x square is equal to minus 4 implies x is equal to plus or minus square root of minus 4. So square root of negative number, square root of negative number does not belong to R. Therefore the renowned mathematician, the great mathematician, Leonard Euler first introduced the symbol I small I, IOTA, iota, for square root of minus 1, with the property I square is equal to minus 1. I square is equal to minus 1 is called the imaginary unity, imaginary unit. Okay, I is an imaginary number. I is not a real number. I is not a real number, but it is an imaginary unit. Okay, imaginary unit. Square root of negative number is called imaginary number. Square root of a negative number. Square root of a negative number is called an imaginary number. Okay, so denote I is equal to square root of minus 1. Denote I is equal to square root of minus 1. That implies I square is equal to minus 1. Hence, square root of minus 4. Square root of minus 4 means square root of minus 1 into 4 is equal to square root of minus 1 into square root of 4. Square root of minus 1 means this is I. 4 square root means this is 2. So this is 2i. Okay. Square root of minus 25 is equal to 5i, or this is plus or minus 5i also, plus or minus is there, plus or minus 5i. Square root of minus 25, square root of minus 100 equal to plus or minus 10i, plus or minus 10i. Square root of a is equal to square root of mod a into minus 1 if a is less than 0. If a is less than 0, that is square root of mod a into i, or this is square root of minus 1, this is square root of mod a into i. Okay. Note: square root of a into square root of b is equal to square root of ab. It is possible only when at least one of a or b is positive. Example: square root of minus 5, square root of 5 into square root of 4 is equal to square root of 5 into 4 is equal to square root of 20. Square root of minus 5 into square root of 4 is equal to square root of minus 5 into 4 is equal to square root of minus 20. Square root of 5 into square root of minus 4 is equal to square root of 5 into minus 4 is equal to square root of minus 20. All are true. But square root of minus 5 into square root of minus 4 is equal to square root of minus 5 into minus 4 is equal to square root of minus 20 plus 20. It is not true. Because square root of a and square root of b, here a negative, b negative, a and b both are negative. It is possible only when at least one of a or b is positive, means minimum gote positive heithia padibo. So in this case square root of minus 5 means root 5i, square root of minus 4 means root 4i. Okay. Therefore square root of minus 5 into square root of minus 4 is equal to root 5i into root 4i is equal to root 5 into root 4 into i square. So this is the root 20, I square means minus 1, so minus root 20. This is true. But square root of minus 5 into square root of minus 4 is equal to square root 20 plus 20, it is not true. Okay. Therefore square root of minus 5 into square root of minus 4 not is equal to square root of 20. But square root of minus 5 into square root of minus 4 is equal to minus square root of 20. Okay. So square root of a into square root of b is equal to square root of ab. It is possible only when at least one of the number is positive. Otherwise it is not possible. Okay. Next, integral power of I. Integral power of I. Integral power of I, since I is equal to square root of minus 1. Therefore I square is equal to minus 1. तो I cube is equal to I square into I. Minus 1 into I is equal to minus I. I fourth, I square minus 1 square is equal to plus 1. I fifth, I fourth into I, 1 into I is equal to I. I sixth, I fourth into I square, 1 into minus 1 is equal to minus 1. I to power 7, I to power 6 into I to power 6 means minus 1 into I is equal to minus I to power 8, I to power 4 square, so 1 square that is 1. I to power 9, I to power 8 into I, so 1 into I is equal to I. I to power 10 is equal to I to power 8 into I square, so 1 into minus 1 is equal to minus 1. I square is minus 1. Okay, I to power 11, so I to power 10 into I, so I to power 10 means minus 1 into I is equal to minus I. Okay, I to power 12, so I fourth cube, I fourth means 1 cube means 1. So I to power 12 means 1, I to power 12 means 1, I to power 12, I to power 12 is equal to I to power 4 cube, that is 1 cube, that is 1. So from these cases we conclude that I to power 4 1, I to power 8 1, I to power 12 1, that means I to power 4 into integer is equal to 1. I to power 4 into integer is equal to 1. From the above cases, we conclude that I to power 4 into integer 4n is equal to 1. I to power 4n is equal to 1. Next, I to power 4n plus 1 is equal to I to power 4n plus 1 is equal to I, because I to power 4n plus 1 means I to power 4n into I. So I to power 4n is 1 into I means I. Next, I to power 4n plus 2 is equal to minus 1. I to power 4n plus 2 means I to power 4n into I square. I to power 4n is 1, I square is minus 1. So 1 into minus 1, it is minus 1. And last one, I to power 4n plus 3 is equal to minus I. For all n belongs to set of integer z. So एटा को मन रखियो, रिमेंबर दिस फार्मूला. तो पावर को आई रो पावर को डिवाइड करियो 4 द्वारा है. पावर ऑफ आई इज डिवाइडेड बाय 4. इफ द रिमाइंडर इज 0, the value is 1. If the remainder is 1, it is I. If the remainder is 2, it is minus 1. If the remainder is 3, it is minus I. Minus I. I रो पावर को 4 द्वारा डिवाइड करिवो, the remainder 0 आसुची तो आंसर हबो 1. रिमाइंडर 1 आसुची आंसर हबो I. रिमाइंडर 2 आसिले आंसर हबो -1. रिमाइंडर 3 आसिले आंसर हबो -I. कहीं एनी नंबर को डिवाइड कले 4, रिमाइंडर में 0 1 2 3 ही पाइबा. तो 0 आसिले 1, 1 आसिले I, 2 आसिले -1, 3 आसिले -I. ओके. एग्जाम्पल, फाइंड द वैल्यू ऑफ I to power 5 3 7. तो I to power 5 3 7. तो 5 3 7 को हम डिवाइड करिया 4 द्वारा. 5 3 7 को डिवाइड करिया 4 द्वारा. तो 5 3 7 को डिवाइड करिया जहाँ ओनली 3 7 को डिवाइड करिया तहा कहीं 4 पॉइंट डिवाइड करला को लास्ट टू डिजिट को डिवाइड करिवो हैला नहीं है. एटा दरकार नहीं किसी काम. 37 को डिवाइड करियो 4, व्हाट इज द रिमाइंडर? 37 by 4 करे 4 9 जा 36, तो रिमाइंडर इज 1. तो वैल्यू ऑफ दिस I to power 537 means this is I to power 4 into 4 1 ja 4. This is 113, 4 3 ja 12, 117, 4 6 ja. Okay, plus 1. तो I to power 4n plus 1, तो this is I to power 4n plus 1, I to power 4n plus 1 is equal to I, तो the value is I. तो last two digit डिवाइड कर लिया मैं रिमाइंडर पाई 37 को डिवाइड करिए 4 द्वारा, तो रिमाइंडर इज 1, तो आंसर इज I. नेक्स्ट अनदर वन, I to power minus 538 को डिवाइड करिए 4, तो माइनस 538 को डिवाइड करिए जहाँ ओनली माइनस 38 को डिवाइड करिए जहाँ, तो माइनस 38 जो डिवाइड करिए 4 द्वारा रिमाइंडर इज 2, रिमाइंडर इज प्लस 2, बिकॉज माइनस 38 जो डिवाइड कर लो, माइनस 38 को डिवाइड कर लो 4 द्वारा, तो 4 9 जा माइनस 36, तो दिस इज -2, तो रिमाइंडर -2 रिमाइंडर नेवर नेगेटिव, रिमाइंडर ऑलवेज ग्रेटर देन इज इक्वल टू 0, रिमाइंडर ऑलवेज ग्रेटर देन इज इक्वल टू 0. ओके, तो देयरफॉर द रिमाइंडर इज इक्वल टू डिवाइजर, दिस डिवाइजर मीन्स 4 प्लस नेगेटिव रिमाइंडर इज इक्वल टू 2. सपोज द रिमाइंडर नेगेटिव आसीगला, तुम ताको ऐड करदेव डिवाइजर सहित, जहाँ पाइब सी आमर एक्चुअल रिमाइंडर. ओके, और यू मे टेक 4 -10 जा, इफ यू टेक -10 जा हियर, दिस इज -40, तो -38 माइनस ऑफ -40 इज इक्वल प्लस 2, तो रिमाइंडर इज 2. सिंस द रिमाइंडर इज 2, तो व्हाट इज द वैल्यू, दिस इज -1, दिस इज -1. I to power minus 538 is equal to -1. ओके, -1. और मन रख, ये जी इभेन रोचे पावर यदि इभेन रोचे यहाँ +1 कि -1 पाइब, पावर ऑड रहिले I कि -I पाइब. If the power of I is even, द वैल्यू इज either +1 or -1. The power of I is odd, the value is +I or -I. है कि these are the homeworks for you. Homeworks, find the value of this, evaluate the following, prove that. These are the homeworks. Okay, so using this you can find the value or proof. Okay, next another note, I to power 4n plus I to power 4n plus 1 plus I to power 4n plus 2 plus I to power 4n plus 3 is equal to 0 for all n belongs to set of integer z. For all n belongs to set of integer z. Okay, 2 I plus I square plus I cube plus I fourth is equal to 0 means sum of 4 consecutive power of I means I square plus I cube plus I fourth is equal to 0 because this is equal to I square means -1, I cube means -I fourth means 1. तो कैंसल सब कैंसल कौन आसला 0 आसला. ओके, नेक्स्ट 3 summation r is equal to 1 to n I to power r means I plus I square plus I cube plus I fourth up to I to power n is equal to remember this formula 0 if n is equal to 4k means n is completely divisible by 4. N is completely divisible by 4. The answer is 0. Next I if n is equal to 4k plus 1, I minus 1 if n is equal to 4k plus 2, minus 1 if n is equal to 4k plus 3. Okay, for all k belongs to set of integer z. For all k belongs to set of integer z. Okay, so example देखो ठीक है. Example, find the value of summation r is equal to 1 to 23 I to power r. Okay, तो आंसर देखो ठीक है. आंसर तो summation r is equal to 1 to 23 I to power r means this is I plus I square plus I cube plus I fourth plus I fifth plus I sixth plus I seventh plus I eighth plus I 9 plus I 10 plus I 11 plus I 12 plus I 13 plus I 14 plus I 15 plus I 16 plus I 17 plus I 18 plus I 19 plus I 20 plus I 21 plus I 22 plus I 23. तो sum of 4 consecutive power of I 0, so this is 0. I plus I square means minus 1, I cube means using this formula, so it is 0. Next A also 0, so first one 0, this is 0, second one also 0, third one 0, fourth one 0, fifth one also 0. Okay, 1 2 3 4 5 term 0 आसीगला. नेक्स्ट I 21 को डिवाइड कर लो 4 द्वारा, रिमाइंडर इज 1, तार वैल्यू इज I. ये है -1. I 22 मीन्स -1, I 23 मीन्स -I. तो कौन देख दो I को I कैंसिल आसला के -1. तो -1 देख 23 को डिवाइड करिया 4 द्वारा, 23 को डिवाइड कर लो 4 द्वारा, रिमाइंडर इज 3. 23 को डिवाइड कर लो 4 द्वारा, रिमाइंडर इज कौन 3. तो व्हाट इज द आंसर? n is equal to 4k plus 3, n is equal to 4 into 5 plus 3, 23 means 4 into 5 plus 3, तो रिमाइंडर इज 3, तो वैल्यू इज -1, तो वैल्यू इज -1. तो तुम कौन कर पावर एटा को तुम डिवाइड कर 4 द्वारा, तो रिमाइंडर इज 0, तो आंसर इज 0. रिमाइंडर इज 1, आंसर इज I. रिमाइंडर इज 2, आंसर इज I -1. रिमाइंडर इज 3, आंसर इज -1. तो डायरेक्ट पुट है ना, नहीं ऐसा करे दरकार नहीं किसी, डायरेक्ट पुट द वैल्यू यूजिंग दिस फार्मूला. ओके, तो सिमिलरली अनदर क्वेश्चन, फाइंड द वैल्यू ऑफ summation r is equal to 1 to 592 I to power r. what is the value? तो 592 को डिवाइड करो, 92 को डिवाइड कर लो 4 द्वारा, 4 2 जा, तो रिमाइंडर 0, तो रिमाइंडर 0 मीन्स आंसर आल्सो 0. आंसर summation r is equal to 1 to 592 I to power r means आंसर 0, बिकॉज 592 को डिवाइड कर लो 4 द्वारा आसी बिलोंग्स टू z, तो आंसर इज 0. तो कम्प्लीटली डिविजिबल बाय 4, 592 इज कम्प्लीट डिविजिबल बाय 4, तो आंसर इज 0. ओके, कॉम्प्लेक्स नंबर. A number can be expressed in the form of a plus ib. A complex number can be expressed. A complex number can be expressed in the form of in the form of a plus ib, in the form of a plus ib, where a and b are real numbers, where a and b are real numbers and are real numbers and I is called imaginary unity, called imaginary unit, imaginary unit. Okay, we satisfy the equation which satisfies the equation I square is equal to minus 1, I square is equal to minus 1. Okay, in this expression a is called real part and b is called imaginary part. Coefficient of I is called imaginary part. Okay, here or in this expression a is called real part and b, that is the coefficient of b, and b is called an imaginary part, an imaginary part. Okay, of the complex number. Okay, complex number extend the one dimensional to complex number extend the concept of one dimensional to two dimensional space by using the horizontal axis, for real part and the vertical axis for imaginary part, vertical axis for imaginary part. Okay, the complex number a plus ib can be identified by a point order pair a comma b in the complex plane, complex plane, in the complex plane. Okay, if z is equal to a plus ib, if z is equal to a plus ib is a complex number, then real part of z, then real part of z is denoted by rez and is equal to rez is equal to a, and imaginary part of z is denoted by imz is equal to small b, not ib, only b. Coefficient of I is known as imaginary part. Coefficient of I is known as imaginary part. 5 plus 8i, so 8 is called imaginary part of z. 5 is real part, 8 is imaginary part. Both a and b, both are real number. A real, b also real. Both are real number. A and b real. Since z contains I, so it is called complex number. Okay, so z is denoted by imz means this is b. Okay, imz, rez means a, imz means b. Okay, example, z is equal to 2 plus 3i. So 2 and 3 both are belong to real number are. So rez is equal to 2, imz is equal to 3. Z is equal to minus 5 minus 7i. Rez is equal to minus 5, imz is equal to minus 7. So you can write this is minus 5 comma minus 7. Okay, next, z is equal to 3, z is equal to 3 means this is 3 plus 0 into I. So you can write 3 means 3 plus 0 into I. Therefore rez is equal to 3, imz is equal to 0. Similarly z is equal to minus 5i. So you can write 0 plus minus 5 into I. So rez is equal to 0 and imz is equal to minus 5. Similarly z is equal to 0 plus I into 0. So rez is equal to 0, imz is equal to 0. Rez is equal to 0, imz also 0. Okay. Note: let z is equal to a plus ib. A comma b belongs to real number r. Is a complex number. I is equal to square root of minus 1. I is equal to square root of minus 1. Okay. Acha. 1. If b is equal to 0, then z is equal to a. Okay, it is purely real. It is purely real. If z is equal to, if b is equal to 0, if b is equal to 0, then z is equal to a. So it is purely real. 2. If a is equal to 0, then z is equal to ib. It is purely imaginary. Real part is 0, then it is purely imaginary. If imaginary part is 0, it is purely real. Okay, purely real. 3. Z is equal to 0 plus I into 0 is purely real as well as purely imaginary. Is purely real as well as purely imaginary. Purely imaginary. 0 is the only number which is both real as well as imaginary. 0 means 0 plus I into 0. 0 means 0 plus I into 0. So real part is 0, imaginary part is 0. Okay. So we can take this is purely real as well as purely imaginary. Okay. अच्छा. Generally complex set of complex number is denoted by set of complex number is denoted by C, capital C or this. Okay. So every real number is a complex number. Every real number is a complex number, but the converse may or may not be true. But the converse may or may not be true. Therefore, R is a subset of complex number C. R is subset of complex number C. Okay. R is subset of complex number C. Okay. All purely imaginary numbers except 0 is an imaginary number. Imaginary numbers are complex numbers, but imaginary numbers may or may not be purely imaginary. May or may not be purely imaginary. Okay. Example, z is equal to 4 plus 3i is an imaginary number. But not purely imaginary. Not purely imaginary. Purely imaginary means real part must be 0. Purely imaginary means real part is कौन हाँ पड़े 0 ही हाँ पड़े है तो here real part is not 0, therefore it is imaginary but not purely imaginary. Okay. Next, equality of complex numbers. Equality of complex numbers. Two complex numbers are said to be equal. Two complex numbers are said to be equal if and only if their real parts are equal as well as imaginary parts are equal. Their real parts are equal as well as imaginary parts are equal. Okay. Two complex numbers are said to be equal if and only if and only if their real as well as imaginary imaginary parts are same. Real part as well as imaginary parts are same. Okay, if z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2 for all x1, x2, y1, y2 belongs to set of real number R. z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2 are two complex numbers. Okay, are two complex numbers. Okay, let z1 is equal to z2, that implies x1 plus iy1 is equal to x2 plus iy2. So this implies x1 is equal to x2 and condition y1 is equal to y2. x1 is equal to x2 and y1 is equal to y2. Okay, x1 is equal to x2 and y1 is equal to y2, that is ReZ1 is equal to ReZ2, means real part of Z1 is equal to real part of Z2, and ImZ1 is equal to ImZ2. ImZ1 is equal to ImZ2. Okay, remember that two complex numbers are either equal or not equal, but two complex numbers cannot be comparable, means z1 greater than z2 or z1 less than z2 is are meaningless. means दुईटा complex number केबेले compare करि परिबो नाही, they are not comparable. किए बड़ किए छोट तुम compare करि परिबोनी, because they satisfy order property. Order property means order pair x comma y is suppose order pair a comma b greater than c comma d, it is meaningless. It is meaningless. Okay, so note two complex number cannot be comparable. Two complex number cannot be comparable. That is z1 greater than z2 or z1 less than z2 are meaningless. Okay, 3 plus 4i is greater than 5 plus 7i. 7 minus 8i less than 3 plus 4i. These are meaningless. Because they satisfy order property. Because complex number satisfy order property. Complex number satisfied ordered property. Okay, तो order property तुम्हारा comparable नहीं. Okay, find the value of x and y if 2x plus 8iy is equal to iqy minus x plus 4. This is two complex number. तो आम x and y रे value बाहर करिबा. Since two complex numbers are equal, so their real part are equal and imaginary part are equal. Okay, the solution given 2x plus 8y into I is equal to I cube y minus x plus 4. This implies 2x plus 8y into I is equal to, this is 4 minus x plus I cube. I cube means minus I into y. So this implies 2x plus 8yi is equal to 4 minus x minus y or minus y into I plus minus y into I. तो equating both side नहीं, equating both side that is REZ1 is equal to REZ2 and IMZ1 is equal to IMZ2. So REZ1 means 2x, this is real part, this is also real part, is equal to 4 minus x, and 8y imaginary part is equal to minus y. So implies 3x is equal to 4 and 9y is equal to 0. Implies x is equal to 4 by 3, y is equal to 0. Therefore x comma y means 4 by 3 comma 0. This is the answer. X comma y means 4 by 3 comma 0. 4 by 3 comma 0. Okay. So x is 4 by 3, y is equal to 0. Okay. These are the two homeworks. Find the value of x and y. Okay. Question number 1 and 2 given. So means find the value of x and y. Hala? Next class we shall discuss algebra of complex number, conjugate of complex number. Okay.